Dear students, welcome to my YouTube channel PCM Academy. Today we will start central force problems and the detailed course on it. So in the last class we have discussed some basics of central force, that was the revision course actually, but from today we will start from the very beginning and this will be the details course structure. So you have to follow each and every videos that I have uploaded, because the videos are in a playlist mode and that are already topic wise discussion, so your concept will be very clear if you see the videos one by one. So if you are new in this channel, then please go to the playlist and see the videos one by one. For each and every playlist there are different playlists for quantum mechanics, for mechanics, for electricity and magnetism, for mathematical physics. So you can go to playlist and you can see. And obviously if you are new in this channel, then please subscribe my channel so that you can get notifications when I will be uploaded a lot of videos in this channel. Okay, so today we will be discussing about central force. Now first questions that arise in our mind about central force, that what is actually mean by central force, what is the definition of central force. Now before going to give the definition of central force, let me divide the central force problem into three categories. Actually central force motions is always analyzed dividing the whole motion into three categories, and the very first one is that the central force motion for single body problem, for a particle, for single body problem. Okay, and I will give the definition of central force differently for these categories. So very first one is single body problem and second one is two body problem. Central force motion of two body problems under central force. So two body problem, and number 3 is more than two body problem, but we will restrict ourselves up to two body problem, and obviously we will discuss about the single body problem. Why? Because the discussion of or the mathematical formation of more than two body problem is too much complicated, and that is recently a topic of research. So mathematically we can't explain, we can't solve the equation of motion for more than two body problem under central force. So this is a topics of research now. This can be a topics of research now. Okay, so we will restrict ourselves single body problem and two body problem. Actually the equation of motion of central force is so complicated that even for two body problem we can't solve it, but there is another procedure to solve the two body problem by using the equivalent system of one body problem. So what we can do by using the Newton's equation of motion, we can solve only the system for one body mass, for one body system. But if there is a two body system, we have a mathematical tool so that we can convert the two body problem to equivalent one body problem, and then we can discuss that, then we can come back to one body problem also. So that I will tell you later on, but initially you need to understand what is the definition of central force for single body problem and what is the definition of central force for two body problem. So for single body problem, if you talk about single body problem, let me tell you separately for single body problem and for two body problem. Okay, now for single body problem, let us take a conventional coordinate system. Suppose this is a x axis and this is a y axis, and suppose a particle is moving along this plane. So such that at any instant of time the particle is here and the radial distance with respect to origin to this point is r. So its position vector you can write it as r. Now if the particle is moving along this line, the particle is always under the force such that the force is always function of r. The force is only depend on r, you can say. It does not depend on any other angular variables. It will only depend on r. If the particle moving along this path is acted upon only by this force, which is only depend on this radial distance with respect to a certain fixed point, and that fixed point is called center or the pole of this central force. or center of this force, you can say center of this force, this is, and the direction of this force on this particle must be away from this point, or towards this point. So with respect to this pole, that is the center of origin, you can say, with respect to this pole, if the direction of force is either away from this point or towards from this point, and if the force is only depends on r, then we can call this force as central force for single body system. So we can represent f of r as the direction is only either in the increasing direction of r or decreasing direction of r. So we can write it as f of r cap with plus minus sign. So this is the mathematical form of central force. But if this central force is depends only on r and its direction is with respect to this point, is away from this point or towards this point, then this force is called central force for single body system. We can take an example also. Let us take an example for single body system that you can understand more easily. So if we take a spring mass system, something like this, suppose we have a spring mass system something like this, or mass m, and now let us suppose that this mass is rotating along this path. It's a circular motion, suppose, and the unstretched length, if the unstretched length of this string is r naught, suppose. Now if it will be stretched along this direction due to this force, so the central force will be acting along this line. So if there is a force on it, so there is equal force along this direction also, that is nothing but the centrifugal force. So here the centrifugal force acting on this system will be depend only on the position r. So if its natural length is r naught, and the stretch, after stretching, its length will be r minus r naught, or you can say that r naught minus r. So it will be r naught minus r, let me suppose. Okay, so it will be k into r naught minus r, or you can say r minus r naught. So it will depend that it is stretching or it will be compressing. So it will be r minus r naught. So the force is F is equal to actually k into r minus r naught. So this is actually, you can say, this is the force, the magnitude of force, you can see this is only function of r. So this is central force motion for one body system. So if the radius is r, suppose if the radius is r naught, suppose, and if the length is, suppose let us say stretching along this direction, so r will be greater than r naught. So r minus r naught will be positive. So F will be k into r minus r naught r cap. So this is the equation of motion. So this k will be m omega square, you know, if this is a uniform circular motion, that's the different case. But the thing is that F is only depend on r. So this is the central force problem. And this central force, the expression of this force, you can say in this form. But what is the form of the central force for two body problem? The form is same, F is equal to plus minus F of r cap. But here two bodies involved. Suppose that gravitational force, you know, if there is a two mass system m1 and m2 which are separated at a distance r. Now the force acting on this particle, that will be along this line joining. Here along this line, that is the line passing through the origin, that is the center of force. But here the line joining the two point. So here the force is depends on r, but here also the force is depend on r, here also the force is depends on r. But here r is the separation between two objects, and here r is the position vector or the radial distance of this point with respect to origin. So this is the basic difference. So here also the central force F will be F of r plus minus F of r cap. But here as gravitational force is always attractive, so it will be minus F of r cap. But you talk about the Coulomb force, that is Q1 and Q2 separated by a certain distance, then in that case that may be plus or minus, because it may be attractive or repulsive. So these are the two body systems. So here what is happening, what is the definition of two body system is, central force for two body system is that the force must be depend on the mutual distance or the distance between two objects, and the force will be acting along the line joining. Along the line joining. Here you can see the force is depends on R, and obviously it is also along this line, but this line is passing to the origin because here is only one system, one body, here two body, so it will act along the line joining. So what is the basic difference between these two systems? For single body system, we have a object of mass, some mass, and that object is moving with respect to some origin, and with respect to this origin the force will be either away from it or towards it. And here the force is again depends on R, but this R is a mutual distance between these two objects, and the force is along these two line, along the line joining of these two bodies. So this is the basic difference of the definition of central of force problem for single body system and two body system. But the problem is that we can't analyze two body system separately, the motion of two body system separately by using Newton's equation. If we apply Newton's equation for this object, and then if you combine these two equations, and if you want to solve the equation, then the problem will be so complicated. So what we will do, we will just convert this two body problem to an equivalent one body problem by using the reduced concept of reduced mass. Then what we will see, we will solve the problem in this frame by considering the equivalent one body of this two body. So if we consider this two body as a system of one body, then we will discuss the motion of this object. Then we will get the result by solving the mathematical equation. Then from that results, we can convert the results for two body system also, So that is the mathematical way that we can discuss the central force problem by using the equivalent one body problem. So we will discuss in the next class that how we can convert the two body system into an equivalent one body system by using reduced mass. So that is completely a mathematical concept that we can discuss in the next class.